On to the sample problems of 7.4. Let's start with number 3. Let's review quickly how to say this, for one. Log base 4 of 16 is 2. They want us to rewrite this in exponential form. Well, log base 4 of 16 equals 2 means 4 squared equals 16. Number 6. Log base 64 of 1 equals 0. Rewrite this in exponential form. 64 to the 0 power equals 1. Of course, anything to the 0 is 1. Okay? So remember, this is the question here is what power of 64 is 1? 64 to the what is 1? 64 to the 0 is 1. Okay? Let's do number 16. I'm just going to use this space here. A little bit of a different kind of problem, so we'll separate it like that. Save paper, though. So number 16 says log base 1/4 of 16. Actually, we shouldn't be doing 16. We should be doing number 9 first. Number 9. Log base 7 of 49. I'm looking for this number. So 7 to the what is 49? That's the question. 7 to the second is 49, so log base 7 of 49 is 2, because 2 is the power of 7, it gives 49. Number 14. This is log base 3 of 1 over 27. Okay, this is a little trickier. This is saying 3 to the what is 1 over 27. It's a tricky one. Well, I can see that here I have a number in the numerator, right? It's 3 over 1. And after I raise it to a power, I need it to be a number in the denominator. So that should give me a clue that there should be a negative involved, a negative power. So when I raise 3 to the negative, I'm going to take this guy and put it in the denominator. It's going to be 3 to the positive version of this power. It's going to be down here in the denominator. So now it's down here. You can think of it as going down here and becoming 3 to the whatever this number is going to be. That's 27. Okay, and what would that power be? Well, that would be the third power. Okay, so think about it. 3 to the negative 3. Right, this is 1 over 3 to the third. And 3 to the third is 27. So this is negative 3. 3 to the negative 3 is 1 over 27. So log base 3 of 1 over 27 is negative 3. Number 15. Log base 16 of 1/4. What is that? Okay, so 16 to the what is equal to 1/4. Okay, it's even a little more of a trick because now it's very similar to what we just did. So probably it's going to be a negative here. Okay, so we're going to have 1 over, this is 1 over 16 to some power. Okay, so now we need this power to cause 16 to become 4. 16 to the what is 4? Well, it can't be, 2 or 3 or something that's going to make it bigger. Okay, so what's the relationship between 16 and 4? 4 is the square root of 16. So how do we do the square root in exponents? That's the 1/2 power. The negative causes this guy to go down the denominator, and the 1/2 is the square root. Right? So this is negative 1/2. 16 to the negative 1/2 is 1/4. So log base 16 of 1/4 is negative 1/2. Number 16. Log base 1/4 of 16. What is that? So the question is 1/4 to the what is equal to 16? Okay, so now there's a number here in the denominator. I want it to become in the numerator. I'd like to flip this fraction over. We should see that by now, with all of our experience with exponents, that a negative will flip a fraction over, right? The negative power, you would just take the reciprocal of that fraction, and then it would make the power positive. Okay, so this negative, that's going to make this like 4, okay? 1/4 to the negative something is like 4 to the positive something. Okay, to the what? 4 to the what then? Would be 16. Of course, that'd be 2. 4 to the negative 2 is 16, right? Because this 1/4 to the negative 2 is the same as 4 to the positive 2, and of course that's 16. So negative 2. 1/4 to the negative 2 equals 16, so log base 1/4 of 16 is negative 2. Let's do this last one, 19. Log base 11 of 121. This actually should be pretty straightforward. 11 to the what is 121? Well, 11, what? Is it the third? No, that's huge. We should know that 11 squared is 121. So log base 11 of 121 is 2. Okay. So just briefly, we'll go over some calculator stuff here. We talked about in the intro video that if you don't see the base of the log written, if you just see log of 10, you assume log what base? Base 10, okay? That's the common log. If you see ln, the base that you assume when you see the letters L and then N, that's log base E, okay? And your calculator works exclusively in these two bases, log base 10 and log base E. So let's just do a couple examples here. 22, I'm not even going to write these on the paper. It's really just a looking up situation. So number 22 says the natural log of 0.43. That's exactly what it says in the book, the natural log of 0.43. I just enter that in, negative 0.8439, okay? The next one is log, so log base 10 this time. Log of 0.746, 0.746. Negative 0.127. Okay, so that's it. I mean, it's super simple. Numbers 20 through 27 are just having you plug these things in. Probably the biggest challenge is not the natural log. The natural log has its own notation, ln. That is really simple. When you see log, that becomes tricky because all of them have log. Log base 2, log base 5, log base 7. When you see log and you don't see a base, you have to remember to assume that it's base 10, okay? Just like we talked about before. When you see the radical, you see the root symbol, you assume that if there's nothing written there, if it doesn't say that it's the third root or the fourth root or the fifth root, you just assume it's the second root, the square root. You assume a 2 is written there. Okay, just assume that when you see log of something, it means log base 10 of that something. All right, so that's the big lesson there. So let's look at number 30 now. Number 30 is 30 to log base 30 of 4. Okay, so I feel like I got a little bit cut short there at the end of the previous video on the inverse properties, right? It would have been nice if we had a little more time, so we have a little more time now, and so I'd like to make it intuitive to you. The end of the story is if you see 30 raised to the log base 30 of 4, you can think of these as canceling out and 4 is left, okay? But let's make it a little more ingrained in our minds that we don't just think of this as canceling. It makes sense to us, okay? So what this is saying, okay, so let's say we didn't know that. Let's say we didn't understand this yet. We just had that box there, all right? Let's look at this guy right here, all right? Let's just look at log base 30 of 4. What's this asking? This is asking 30 to the what box here. To the what is 4? Okay, well, I don't know about you, but I am not that good in my head thinking about 30 to the what is 4. I can't come up with that. I know it's going to be some kind of a fraction. Other than that, I don't know. And it's probably going to be like not a very nice fraction, or even a weird decimal or something. But whatever it is, whatever that power is, I'm just going to give it a name. Let's just say that thing is x. Okay? Whatever this thing is, it's x. Okay, so this guy right here is x. Log base 30 of 4 is x. X is the power of 30 that gives me 4. Okay? So 30 to the x is 4. Well, look at what we have here. What is this right here? This is log base 30 of 4. We just said log base 30 of 4 is x. Okay? So this thing here is x. It's that power. Okay? And what's 30 to the x? 30 to the x is 4. Right? It's 4. So you can see that cancellation happening. When you take 30 and you raise it to the log of the same base, those two guys cancel out and you're just left with what's right there. All right? Let's look at number 29. Actually, let's look at just an example I'm going to make up. Okay? How about 5 to the log base 5 of 25? These are easier because we can actually see what the numbers are. Log base 5 of 25. We should be able to figure this out by now. What power of 5 gives me 25? 2. Okay? So 5 to the 2. 5 squared. What's that? It's 25. Right? You see what's happening is I'm saying, what's the base, or what's the power of this base that gives me this number? What is it? That's the question. What is the power? What is the power that gives me 25? Well, whatever it is, I'm raising 5 to that power. Whatever power it is that gives me 25, whatever power of 5 gives me 25, that's what I'm doing. I'm taking 5 and raising it to that power. So I'm just going to get this number back. Okay, so if you see, for instance, b, log base b of x. If you see the same basis here, you're just left with x. Okay? Let's look at another example. Number 34. Log base 5 of 125 to the x. Okay? The first thing we need to recognize is this property that we may not have fully gotten to cover. So let's cover it even more so now. Let's say log base 2 of 2 to the third. Right? So this is one we've talked about. It should be a little clearer. I think this one's a little easier, more intuitive than the other. Log base 2 of 2 to the third. Okay, this is what I should have written. Let's write it in exponential form. What's the question that's being asked here? We're asking 2 to the what is equal to 2 to the third? Well, 3 would be the only thing that makes sense to be in that exponent. Right? So this must be a 3. So you can see I have the same base here as I have here. This gets left. Right? What should I raise 2 to get 2 to the third? Well, 3, obviously. All right? So if I had log base 5 of 5 to the something, then I'd have that canceling that would happen. So that's what I'd like to do. I'd like this to be log base 5 of 5 to the something. Right? So I should, in my vast wealth of knowledge of exponents, see that this is 5 to the third. So this is log base 5 of not 125, but 5 to the third to the x. And I can rewrite this as log base 5 of 5 to the 3x. And I see I have the same base here as I have here. So these guys cancel out, and I'm left with 3x. Okay? So your task here is to take these bases here, these numbers, write them as this guy to some power. All right? So I hope this is helpful. Let me know of any questions. Thanks for watching.